Welcome to The Elements, a visual exploration of every known atom in the universe. Today we will be starting our exploration with 76 osmium. Now, osmium joins gold and other metals like copper on a very short list of metals, like transition metals, that are not dull or shiny silver. If that would have been the case if it wasn't for its bluish tint, that it was so faint that you have to work to convince yourself that it's actually there. Practically though, it's another silvery metal. It isn't just any other silvery metal though, it is at least as expensive as rhenium, and on the brittle scale of hardness, which is how far a ball penetrates the material when pushed into it with a great force, osmium is the hardest metal element. It's really hard as a metal. Not the hardest material, but not the hardest element, but the hardest metal element. Osmium itself is found naturally with indium together in a rare but naturally occurring alloy known as osmiridium, or iridosium, or iridosium, depending on who you ask. And this extraordinarily hard metal goes ahead and gives us a few unique cases in its practical uses. It's very durable that people go ahead and make themselves think of it as osmium. Osmium is all like, hey, you know what? I'm the hardest metal ever. If you use me, it'll be very durable for the rest of your life. And that is very convincing in certain cases. Like there's this thing called the Red Devil. It's basically just a needle, a gramophone needle, but the gramophone needle is coated with osmium, and so it's like it will last for hundreds and thousands of years. It doesn't last hundreds and thousands of years. It just says last up to 5,000 plays. What you're seeing on the screen here is a single bead of osmium with a very faint blue. Osmium itself was tipped into several metals to make them a bit more durable, but that's basically its purpose. Its atomic weight is 190.23, its density is 22.59, its atomic weight is 185 picometers, its crystal structure is a hexagonal prism. And 5D is starting to come up, and it has a medium. It's one of the metals with one of the highest melting points ever. It also has one of the highest boiling points ever. This is the first element that we've seen so far, according to the series, that has a melting point of 3,000. Next up, we have 77, iridium. Iridium is widely quoted. The most widely quoted value for the density of iridium is 22.65 grams, which makes osmium 22.61 grams, making iridium the densest of all the elements. But those values are simply just wrong. The correct values are 22.59 grams for osmium and 22.56 grams for iridium, making osmium the densest metal of all time. Also, it is only 0.1% that is a difference. You might be thinking that the density would be an easy question to settle with careful management, that. But when people talk about the density of an element, they mean the density of a perfect single crystal of a perfectly pure sample of that element. If that is not the case, not much else can be done about it. At least in terms of science, at least. Preparing such an idealized sample, it's just not worth it that much. Because it's practically impossible to make that pure of a sample. Even getting close can be difficult in some cases. An accurate method is to use an X-ray crystallography to measure the spacing between the atoms in the sample itself. And then again, that's still hard to do. Because of iridium's high cost, it's only used in certain places where you'll need a little bit of it, such as an iridium ion core. So there's not that many practical uses towards it. It has 192.217 atomic weight. Its density is 22.56. Its atomic radius is 180 picometers. Its crystal structure, it's a cube. And, well, 5D is starting to be filled up, but please finish it before you go to 5F. It won't. Its electron atomic emission spectrum, it seems to be a little bit wonky. It seems to be more contained on one side. It also has a really high melting point, also not as high as iridium, with probably a higher melting point as well too. Next up, we have platinum. Platinum is one of the king's metals. Platinum is even rarer than gold, making it even more expensive than gold. It's the most prestigious element, period. Well, since gold is great, but platinum is always better. Gold credit card, there's nothing compared to the platinum credit card. Platinum is more abundant in the Earth's crust than the other platinum group metals such as the rhodium, osmium, iridium, and even gold. but it is significantly more expensive because its demand is so high. In fact, its demand is so high too because it's a little bit rarer than gold. Platinum is so important in laboratory and industrial applications. Despite their absolutely outrageous cost, you can buy things like solid platinum bowls, crucibles, filter holders, and even electrodes. They are ridiculously costly, though. More than any other metals, though, platinum is able to withstand several particle acids and high temperatures. Almost anything you throw at it, it will most likely resist it. Just as important as it is to the resistance to corrosion, as in palladium, platinum's ability to catalyze reactions, you can even go do those towards gasoline, making it kind of useful in those too. Platinum spark plugs are now quite common and last nearly the life of a car. Yeah, and platinum electrodes resist corrosion, which makes it really useful when you're using conductivity testing. Electrodes for delivering neuropathic electrical pulses can have platinized thread inside them because they need to be durable. Why would you want to use undurable material inside something that'll go into the brain of someone? Wow. That's kind of why it's used in jewelry as well. Its atomic weight is 195.078, its density is 21.090, its atomic radius is 177 picometers, and its crystal structure, it's a really straight cube. I have to say it's really straight cube, mainly because that's the only way to describe it. Boom, here we go. It has a really high melting density, also not as high as the ones in platinum, not as high as the ones in osmium or iridium. It still has a really high melting point though, a boiling point. And next up we have the king of the metals that have only been used for the kings. Gold is the gold standard of all metals. Number 79, AU, Orium is great. Rhodium may be the most valuable, but no one lusts after the way they go ahead and lust after gold. Only carbon in the form of diamond inspires a fever that can be matched by gold. But diamonds are temporary, easily destroyed by heat. Gold though, well, gold is great, and diamonds can be synthesized. Fool's gold though, it's worth nothing, and it's terrible. It will shatter, fool's gold. But gold will just flatten. Gold is inherently valuable. There is very little of it around. All the gold ever mined in human history will fit in a cube with 60 feet on each edge. And if you meet one of those nuts suggesting that our money should go back to our gold standard, you might point out that at current costs, there's just not enough gold around for everyone to do this. There simply isn't enough gold to go around. Gold is undeniably beautiful, that is true. Of all the metals, it is the only one that is both colored and whose color keeps its shine and beauty forever. Yes, it will shine and have its beauty forever. You can find a piece of gold lying on the ground where it has been for a million years, pick it up, and then dust it off, and it will shine for you as it has been waiting for your whole life. As waiting for this moment for your whole life. Billions of years from now, when the aliens go ahead, come to rescue the last artifacts from Earth before our sun explodes, well, King Tut's sarcophagus will still be as shiny as it was today. And today, it's still as shiny as it was like several thousand years ago. Gold itself is terrifically useful. It is a good conductor of electricity that absolutely does not tarnish, making it one of the best materials for electrical contacts. When conductors go ahead and join two circuits together, you really need some gold to go ahead and make that connection yourself. So much gold is used in electronic devices that recycling them to recover the gold is very big business. Gold has fascinated and even inspired us since before those words even exist. Fascinated and inspired. We have lusted after them, we have killed each other after them, and we have even used currency after them. Also, that was discontinued after realizing that's a little inefficient. We go ahead and create jewelry out of them. We go ahead and create electronic parts out of them. Mostly though, we use them for jewelry. Its atomic weight is 196.986655. Density is 19.3. The atomic weight is 174 picometers. Its crystal structure, it's a cube. And 5D has been full. Now we can go ahead to 5F, but 6S has gone down. God, that is annoying. It has a pretty varied range of atomic emission spectrums, and its electron filling order, I just mentioned it, it's a really low, for metal standards, that is, really low melting point and a pretty low boiling point. Also, that part is standard, the boiling point. This is a sheet of gold, 500 atoms thick, and so fragile it can be only picked up with static electricity on the end of a red squirrel hairbrush. Otherwise, it will just shatter. Number 80 is mercury. Mercury, as most people will know, is the only metal that is liquid at room temperature, with with some other exceptions. But depends on where room temperature is. Mercury itself will freeze in the Arctic, and mercury in regular houses, like the ones in the United States of America, and the Middle Coast, will go ahead and it just turns into metal. It just melts into a molten pile of metallic metal. Never drink it yourself. It's really toxic. Liquid metal literally drips from the walls of the caves of the ancient mines in Almaden, Spain. Now, this liquid must have been very magical towards them because they realized it was a metal. No framework existed to understand its place in that context. Yes, even mercury today is every bit magical, but no matter how much you know about it, the more you get, the more magical it gets. It used to be used in thermometers, but then they realized that if you use fever thermometers with mercury in them, you will probably poison the person instead of helping them measure their temperature, because that temperature will be useless after the guy has eaten some mercury. Mercury, though, has a downside. It's really toxic, and it builds up inside bodies. If a fish eats it, it just transfers into the next part of the food chain all the way to the humans. Same amount of mercury. It doesn't get digested at all. You use sometimes in the pigment scallion, which is just mercury sulfide, and when you go ahead and freeze it enough, you can really make some interesting sculptures like fish, whether you would want to make fish or something like that. Fatty marine animals will accumulate mercury when they eat it, such as tuna, and that is terrible for us humans, mainly because we eat those things and that mercury will go inside of us, and no one wants to eat mercury. Mainly, it used to have several practical uses, such as batteries and paint, but then we later realized mercury was so toxic that we had to ban it. Its atomic weight is 200.59, its density is 13.534, its atomic radius is 171 picometers, its crystal structure is an oblong cube. Obviously, it would be a liquid at room temperature because its freezing point is less than 0 degrees. Or is it about 0 degrees? And its boiling point is no higher either. If you just put it on the stove, it'll turn into mercury gas, and no one wants to drink that. Well, this one is basically the same. Its atomic filling order is the same as gold. It's just that 6s has been filled. And it's about similar to the atomic emission spectrum of gold, but it's more varied. And it's not accumulated on one side. And that's it for today. I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, Sean out. Peace. Bye-bye.